Hey class, this is the second half. Now this is not an ice problem, which means that, it really should be easier because ice problems are not the easiest thing in the world. So, well, we're going to get there. We're going to get to whether it should be easier or not. But let's take a look first at some of this stuff that we got going on. I got a volume of 15 milliliters of 40, there we go, 0.4 molar NaOH is added to 25 milliliters of 0.4 molar HF. So I have the same concentrations but different amounts. Okay, so let's assume that the volumes are additive, which means that 25 plus 15 equals 40 milliliters after we add the stuff together. So let's go back to the equation that is at the bottom of the previous page, and it looks something like this. It looks like HF plus NaOH here, and this goes to water because it's an acid-base reaction, plus F minus. Now what we can do, that would be of course NaF. What we can do is we can get rid of that, because Na, as you know, is that would be considered a spectator ion here. So this is just the net ionic equation. Let me get rid of that so it's like not in our way at all. That and that. Okay, good. So notice that there's all ones here, which makes this calculation a lot easier. So here's what's happening. If I want to know how much HF is left over after the reaction, what I have to do then is figure out the number of moles of both HF and NaOH, and that's actually pretty easy to do. You guys know that molarity equals number of moles divided by volume. So if you're solving for moles, it's just moles equals, how do I keep doing that? Molarity times volume, like that. So all I have to do is multiply the two. Now here's the one problem with this. When I multiply for, let's do this for HF. So for HF here, there we go. Okay. For the number of moles, I'm going to multiply, but I have to change. So it's the 0.4 like that. You guys know that moles, molarity is moles per liter. And if it's moles per liter, then I have to change, obviously, the milliliters to liters. So that's going to be, the milliliters of this is 25, so 0.025 liters. I move 3 places to the left to go from milliliters to liters. Okay, and then whatever that equals. So whatever that equals, where's my calculator at? So whatever that equals is 0.04 times 0.025, and that gives me 0.001 moles. There, that's of the HF. Okay, now I'm going to do the same thing for NaOH. So moles equals 0.04. Yeah, okay, whatever. And again, that's moles per liter. So I change this one now to 0.015, like that, liters. And 0.04 times 0.015 is 0.006. So let me do it this way. All I have to do for the HF here is subtract the amount of OH minus that reacts with it, number of moles. Just subtract it, and that will tell me how much I have left over. So this is 0.0006 like this, which means when I subtract the two, what I have left over then is going to be 0.0004 moles of HF. So this is the amount of moles of HF. Calculate the number of moles of HF, so that would be 0.00040 moles of HF. All I did was subtract the two once I converted them to moles. Okay, so that was letter C. Good. How about letter D? Calculate the molar concentration of F minus in the solution. Okay, well, so here is my number of moles that reacts to form the products. So it'll kind of be like as I go through this, moles of HF are the same as the moles of the NaOH added. So that means moles of Na should be this, because this is the number of moles that reacted to form the water, and the F minus. So where are we at here? So that's easy. The question, though, is calculate the molar concentration. So what's the molar concentration? Well, the molar concentration is the number of moles divided by the total volume. So what's the total volume? If I have 25 milliliters plus 15 milliliters, that equals 40 milliliters. But 40 milliliters means that I have 0.040 liters. So I simply take this, nope, too many zeros, 0.040 liters, like that. The 0.0006, so let's do that, divided by 0.04, and that gives me 0.015 molar concentration of F minus. So this part right here is letter D, like that. That's kind of all screwed up, but you can still see where everything is. So this right here, then, for letter D is 0.00, 15. That's the concentration of F minus. That's only 1 0 in there. I'm not sure. Yeah, 1 0. Okay, 0.015. There we go. F minus. Okay, sorry about that. There's letter D. So the question is then, of course, calculate the pH of the solution. So the amount of HF that's left over is this right here for letter A. Now, that will be, okay, so maybe this one isn't. Okay, so maybe this one is an ice, like this, an ice problem. Because now I have, so this is for letter E, okay? And I have 0.00040 moles of HF. The total amount is in 0.040 liters, the total amount that I used for the other problem. Okay, so all of this equals a concentration of HF, and remember HF goes to H plus and F minus with the initial concentration of whatever this is. So I go 0.0004 divided by 0.04 equals 0.01. So this right here is 0.01 concentration minus X. This is 0, 0, and then plus X, 0.01 minus X, X, and X, which means X squared here. Now what I'm doing is I'm doing my Ka, still hasn't changed. It's H plus F minus all over concentration of HF. So all of that still equals 7.2 times 10 to the negative fourth. That hasn't changed either. So now I got X squared over 0.01, and I got rid of this. Boom, boom. Get rid of it. Gone. 5% rule. So it's gone, which means equals 7.2 times 10 to the negative fourth. So this is actually pretty easy because I just simply take these two, I multiply these two, and that gives me 7.2 times 10 to the negative sixth times 7.2 E4 minus times 10 to the negative sixth. I take the square root of that. X, that's X squared equals that. I take the square root of both of them, and I get 0.00268 as my concentration of H plus, because that's what X equals. Hang on, we're almost there. pH, this is asking for the pH, equals the negative log of the H plus concentration, which means negative log of 0.00268, like that. So I take this here and make it negative and do the log. That was not it. I take this here, 0.00268, take the log, and then make it negative. So I get a 2.57 as my pH. Boy, that was easy, huh? There we go. 2.57 as the pH. Okay. Enjoy, guys.